So we have a type called enum, defining enums. And let's see how we define a enum. And enum similar to a class definition. And it's just very similar to a class definition. The difference between enum and a class is, in case of enum, okay, we got fixed objects. The objects, what are all the objects for the class, are part of the definition itself. Normally, we define a class and then separately somewhere else we'll just create the objects. Where required, wherever required, we'll just create the objects. Okay, but here I have a class. What will be the objects for the class is part of the definition. You won't have any other objects. Okay, fine. So I have this class which is going to have only these objects. So objects are part of the definition. Okay, fine. So fixed objects, they are pre-created, you can say. Okay, they are pre-created objects for this type. Okay, so definition wise we'll see much of the things very similar to a class definition, but one major difference is there, which is here we have to include a list of objects. Okay, when we define a enum, we also include a list of objects. Okay, so if you look at the syntax, you specify or modifiers by saying, okay, it's a public, and you might say it's a public enum, or you may not declare public. Let's say we want to have, now another thing, where do we use enums? Since we have fixed, objects are fixed, okay, it's defined, you don't allow anyone to create new objects. So scenario where we find those data types where objects are pre-decided, you won't have more or less, find they're always fixed number of objects. Fine. We use enums where we have got fixed number of objects. Okay, fine. So enums are just like a class definition. Fine. So let's start looking at the syntax for enum. Okay, so it goes like this. We'll have, so if you have to define an enum, you'll say, okay, let's consider one example here. Okay, so where we find that we have fixed objects, right? Fixed number of objects, fixed objects are there. For example, you have months. Fine, months in a year. How many months? 12 months? It depends on which calendar you follow, right? Okay. Fine. You can have 13 months also, right? No? Anyway, so let's use the Gregorian calendar. Fine. And so accordingly, we'll have, so let's try to define a enum for a month. So we'll say, for example, we'll say public enum month. Okay, in case of class, we'll say, okay, we have a class, fine, public or abstract. You have your modifiers, keyword class, class name, then we use the keyword extends and specify a superclass. In case of enum, no, we are not allowed to use extends. Fine, we don't specify a superclass for enum type. If it's a enum type, the superclass is pre-decided. Okay, the superclass for a enum type is always going to be the class called enum. There is a class called enum, and this is a class. Enum is a class, capital E. Okay, but this class, fine, you can't create a subclass. When you define a class and say, I want to extend from the class called enum, that would be a compilation error. Only way to have a subtype of the enum class is by defining the enum types. Okay, if you define an enum, it's always going to inherit from the class called enum. And you don't say extends enum anyway, because you use the keyword enum, that means, oh, I'm extending from enum. And like a class definition where we said, oh, it implements interfaces, and a class will implement interfaces, even our enum can implement interfaces. It's just like a class, but where the super class is always fixed. Okay, so you are free to say implements. Fine. In case of our month, we don't need. Okay, in our case here, fine, the month enum, we here may not need to implement any interface. But syntax point of view, fine, when you are defining an enum, you'll have, you don't put extends, but you use implements. You can use implements, interfaces, similar to a class definition. So just like a class definition, except for the extends is missing. Okay. Plus, you don't say abstract here. Okay, don't put abstract or final over here. Fine. So let's put this. We are not implementing interfaces. And in case of month, okay. And then in this definition, it's divided into two parts. The first part is the object list. The list of objects which you want to have for this. Okay, fine. So in our case of month, we have the list of 12 objects. So we can say, okay, I would like to have an object called Jan. Fine. I would like to have another object called Feb, and so on. Fine. I have those objects. Comma. Fine. So comma separated list of objects. Okay. Once you put those objects, okay, let's say I just put this much only in my definition. I said it has two parts, right? So we have only put the first part, which is about list of objects. Okay. So because of this list of objects, what is becoming usable? Fine. What we can now use? Oh, I want to have what are the objects of the type month? Which are all the objects of type month? Jan. No, it's not just Jan. Outside the enum type, I will have to use month dot Jan. Fine. It's available as month dot these objects. These are your objects. Okay, and then I said it inherits from the class called enum. Okay, what methods is it inheriting? What are the methods it is inheriting? So I might have some object. So if I have somewhere I have declared a variable called month m. Fine, it's a variable. Now to m, anything could have been assigned, right? It could be what can be assigned to this? Oh, it can be either of these objects, or it might be a null. That's the only thing possible. There's nothing else which is possible to be assigned to m. Okay, fine. Now, what are the methods which I can use on m dot? What methods can I use? Methods from object class, that's one. But then I can also use methods of enum, instance methods, not the static. I'm not talking about static. We do have some static methods, we'll come to that. Okay, but we can use methods of enum class. Okay, let's see what are the methods. And these methods of enum class, so let me mention a few methods from enum class now. The methods from enum class are, these are final. What I'm mentioning is a final method. Okay, the method returns a string. Method called name. Okay, there are two methods which you will inherit. Another method is a method to return int. Name of the method is ordinal. Okay, two methods. One is a string, other is a int. one is returning string, other is returning int. So every enum object has two characteristics. It has a name and an ordinal value. Okay, what's the name and ordinal value for the first object here? What's that string? The first object which you have listed, what's its name? Jan. So if I have m, right? If I say m dot name, okay, that would return to me whatever spelling you have used here. Okay, so if it is on the first object, the string returned would be JAN. That's a string, as a string. If I say month.jan, that's of type month. Fine. Month, okay, month.jan is a type month. Fine, m is equal to month.jan could have been there. But if I say m.name, that's a string. So what spellings you use here in the listing becomes a property for the object. Okay, what would be m.ordinal? What's m.ordinal? For Jan, the first object, what's the ordinal value of the first object? See, the property is picked up from the way you have positioned them. Oh, because it's here, it's the first one you have listed, the ordinal value is 0. The second one which is listed, the ordinal value is 1. And so as you list the objects, you are actually putting two properties into it, the name and the ordinal value for the object. So it all depends on how you ordered them. Ordinal value depends on how you have ordered them. Fine. So m.ordinal would be, for the first object it would be 0, for the second object it is 1. Okay, another final method, the enum class which is here, this one is implementing comparable. That means it has the compare to method. And how does it compare? How is the result of comparison going to be given? And that compare to method is final, cannot be overridden. You can't change that logic of comparison. So the logic of comparison is built in the enum class itself. And you can't be changing that. And how does it compare? The one which is coming earlier, whose ordinal is less than anyone which is coming later. So the way you have listed is basically defining the order for comparison also. The compare to uses this ordering only, and it's not changeable. You can't override the compare to method, not allowed. It's a final method. Final in the enum class. Okay, so some methods which are from the enum class. Fine, we have seen some methods from the enum class. Okay, now let's see if we can add methods. It's, as I mentioned, this enum is just like a class definition. Additional thing was the listing of, fine, it's a object list which we have. Okay. Fine, and then the second part is a class definition. What goes in a class? When we define a class, what do we put in a class definition? We put variables, instance variables. We can have methods of our own, additional methods. We may even override some methods if they are not final. Fine. And we can have constructors. All that is available for enum definition also. Okay, let's try some of those things here. Fine. So the syntax goes like this now. Now, first part, object list. Now to separate that, to indicate end of the first part, and I want to include something in the second part, you must have a semicolon. Just put a semicolon. Otherwise, it was just comma separated things only. Put a semicolon to indicate list is over. Fine, object list is over, and I can include my class definition. Fine, so methods which are available, which are inherited rather. Fine. I'll also give you a couple of static methods because they would be available even if you have not done a second part. There are a couple of static methods which are always included in any enum if you are defining. Whatever enum you define, you get two static methods. The compiler adds them into your enum. Okay, let's see those two static methods. What are they, right? So what it does is one of the methods here is a static method. So we are now looking at static methods without doing any second part. Okay, we have not done second part. Still, you get two static methods. Okay. So for the month, fine. So this is very specific to which enum. So it all depends on this name. Okay. So in case for the month enum, okay, there will be two static methods which automatically happen to be available. So in this, you will have a static method which returns an array of month. Name of the method is values. So if you want to know what are all the objects in this enum, you want to get them as an array, you have a method month.values, static method, use the class name. So enum name. So month.values will give us an array which would contain, fine, it would give us an array which would contain all the objects which have been listed in the same order. And another useful static method would be a static method to return a single object of month. Name of the method is value of, where the parameter is a string which is the name. So if you know the name of an object as a string, you can fetch the corresponding month object. And for example, I might ask the user to give me the name of a month, the 3-letter name of a month, and whatever he gives, I want to give something based on that. So I have to fetch the month object, given a string. Month is given as a string, and I get the month object for it. So that's what is available by this method, value of. Okay. Now here, look at one thing. The convention which we follow normally is the objects are listed with all capital letters. Fine. Because it's a convention. These are like constants. These are like constants. Constants we normally use uppercase, all uppercase. Okay. Right. So we have this all uppercase thing, and then so whatever input the user gives, I'll convert to an uppercase and use it with the value of method and fetch the month object. Right. So that way you can fetch any month object. Clear? Getting all the objects or getting object by name, that's what is available. Fine. When we get all the objects, they would be in the same sequence. Okay. So let's add, I think I'll write the code in the code editor, and let's keep on modifying. Let's now, so in the second part, fine, let's define the second part where we can add variables, methods, and even constructors. Right? So let me show how it can be done. Okay. Okay, so let's make it part of a package called util. Okay, let's have some package util. And then we define a public enum for month. Okay. Right. And for this enum, yeah, we decided to have the object list. So I'll go with the initial definition. We'll keep on making modifications in this. Okay. Okay, I put the semicolon so that I can have the and second part. Okay, see, if I don't have the second part, semicolon is not necessary. Okay. And see, look at the convention. We normally have this convention 1 per line. You could have put all in 1 line also, but the convention is to keep 1 per line. Okay. And even the last one, you can observe what I have done. In the last one, I have put a comma. Not necessary. Fine. But even if you put one extra comma there, that's fine. Okay. Fine. So, say with this one, if you have to change the order, it's fine. It becomes very simple if you do it. Keep it this way. Just exchange any 2 rows or anything. So it's just a small help there, right? Okay. So that could be one. Now, let's have something additional for the objects of month. Every month may have, what's the maximum number of days it has? Fine, so it's one attribute. So let's add one attribute, right? So we can have private variable. Fine, instance variables normally will keep private. Int max days. Okay. Then if we have a variable, we might put a constructor. Okay. So now another thing, for enums, constructors are always private. Fine, constructor is going to be private. Fine. Why? Fixed objects. You don't want to allow someone to create a new object. You have the object list, that's it. No one can create another one. Fine, the object creation is here only. Remember this. This 12, whatever we have written, that's the object list. That's the object creation also. This is the place where the objects are created. Okay. So now let's add a constructor here. So we have a constructor, and you may declare private, or even if you don't declare anything about the constructor would be considered as private since it is in a enum. Inside enum, constructors are always private. Okay, so I have not mentioned private, but it would still be private. I don't mention anything. Okay, and it takes one parameter which is for the max days. Okay, and then initialization. So now the restriction is, if I have to create any object, I must have an integer also. If object is to be created, you must have a integer. Where am I creating the object? You are not directly saying new, but this is the place, we have listed it here. That's the place where we are creating the object. So here's the place where, for example, I'll put it like this. Fine. Okay. Or someone could actually be overloading the constructor and saying, okay, you want to overload constructor? And for example, I could have done this way also. I could have said, okay, let's have, if you don't specify, I'll consider it as 31. Okay. In that case, yes, I don't need to specify anything for these ones. Okay. Constructor overloading. Fine. Just similar to a class, what we do in a class, we can overload constructors. Fine. We have method. Okay, let's have method. We'll have a public method which returns integer value. Fine. Get max days. And just says return this dot max days. And you have method to return value max days. Fine. Now another point was we have the toString method in the object class, which by default for enum is returning the name, but it is not final. You can override. By default it is returning the name. Fine. Now here I have the 3-letter names as the object names, and they become the object name. But I can have the full name also, right? Each one has a full name. It's an attribute of the month, full name. Okay. So I can add another private variable string full name. And I add in my constructor a string I'll take one parameter at least now. Okay, I've updated the constructors, added one, and then because the constructor is updated, I'll have to change here also. I must specify and okay, we add our method also, public string get name. I'll just say get name. I'll just shorten the name. Return this dot full name. Fine. Enums, defining a enum. Fine. So the second part you can say is just like a class only, right? Class having variable, class having methods and constructors, overloading of constructor. You can overload method wherever required. And you can include static variable, you can include static methods. Okay, well, let's add the static method main. We can keep main here also. It's just like a class definition. So we could have main here. Fine. So let's put main. Let's write some code here. Write some application. We can run this. Okay. Okay. And order doesn't matter much after summing. So let me put it here. Public static void main string array. Fine. Okay. And then let's take command line argument as 3-letter name of a month, and from that we'll create the month. We'll get the month, fetch the month object. We are not creating. When we are not saying new, we don't have to say new. All these are already created. When you can't create new object, and then give the details about that. Okay, for example, I'll say, okay, string, the from is greater than 2. In that case, there's a different thing. Okay, and you can include. So if someone says no, on November, if I say is between this and this, yes. If I do it on March, yes. Okay, inclusive, both are included. Okay, when I'm using is between. And so try that exercise, and but take care of this case. And that will be one exercise which you have. Okay, so tomorrow you will be having exercises. And tomorrow no theory, that's only exercise. Fine, clear? Okay, now I am now assuming you got this method. I'm assuming you got this method. And let's build another class called, another enum called season. Okay. Okay. Fine. So let me start defining the enum for season. Okay, you'll have to tell me about the seasons. What are your seasons? And the months they, so we'll have like this. Okay, yeah, then? What are all the seasons? Yeah? Start with winter? Okay. What's the start month? And what's the end month? Month dot? Winter starts in Jan, okay. Month dot ends in? I think it should start in December. Let's start in December. Month, yeah, which is the end month? Winter. Goes on till May? Feb. Okay, let's have Feb. And December to Feb. Next, spring. Month dot March to month dot April. May is summer. Yeah. May, June, July. Okay. July or August, I don't know. July? Okay, then? Autumn? Fall. Okay. Starts in August? October or November. Let's cover everything. Yeah, we can't leave a month blank, okay, without a season, and we don't need to have overlaps. And you can make the corrections, but yes, we have those. So we got 4 seasons listed here. Okay. So private, month, start. Okay, it starts here. Private, month for ends. A constructor for season says, okay, I'll take month, which is the start month. I'll take another month, which is the end month. Okay, similarly, you have the month ends, and this says return this dot ends. Okay, so that's a getter methods, but now the important method which I want is a static method. Given a month, get me the season. Input is month, but get me the season for it. Okay, so you have a public static method, returns season. And if we don't have any season object, we don't apply it on an object, so static method. I want to actually, given a month, I want to know the season for it. So method name is get season for a given month. Oops. Yeah, how do we write this? Assume you have that method is between, okay? And we can assume the method called is between. Take all the months, not months, sorry. Take all the seasons. And take all the seasons and then have a for loop for each season in seasons. If that is the case, you didn't find. It didn't match anything. And that shouldn't happen. Okay. You should have been covering every month. And so yes, this depends on the method. Fine, you should have the method called is between. Okay, so this is dependent on month. Season depends on month. Okay. Okay, let me save this. And you could add a static method where input is, or in that same month, and whatever we have done in month, we could add one additional thing. The season is so and so. And we have given the name, we have given the full name, we have given the number of days, and also mentioned what season it is. So input from the user is just a month, and you give those three values. Now let's come to another one, slightly advanced. Okay, and we'll see one more enum now. Okay. Fine. Any questions till now? Yeah. And we have done those two different enums. Fine. So enum, just like a class definition, addition of object list. Okay, fixed objects. Those are the only objects you'll have. There is nothing like saying new month or new season. You can't create objects like that. Okay, so let's have another enum which is for arithmetic operators. We have fixed number of arithmetic operators: addition, subtraction, multiplication, division, and modulus. Fine. So we got 5 operators, right? Fixed objects. We can go for enum. Okay, so let's try that. Okay, so again we have the packages util, and we have the public enum for operator. Yeah. What do we do in this? Which are the arithmetic operators? Add, and maybe we'll have attributes. So I'm adding a few things here. We'll have an attribute which says what is the symbol used. Okay, find the symbol. That can be, so every arithmetic operator has a symbol. You want to use the X thing here? Maybe it's just a symbol. We are not using it as a line. Division. We don't have that symbol. Let's put slash then, right? Okay. Private variable for string, symbol, constructor for takes a string, okay. So fine. So we got the methods in place. Now we would like to have a method which takes two double values, applies the operator and computes. Okay, so we would like to have a method which is a public method, returns double, method name is compute, takes a double A comma double B. Yeah, and that's my method. How do we write this method? If there is an operator, I should be able to apply that operator and compute the value. Now this method has its own implementation for each of the objects. Each object has its own different implementation for compute. Compute for add would say just return A plus B. Compute for subtract would say return A minus B. When there is a different implementation for each one of them. Okay, so what you can do here is, if that is the case, what you can do, okay, now before that, question. Anyway, I'm giving out the answer first. Okay, can we have a enum? Can a enum have, enum will always have objects, right? Can a enum have abstract method? Can we have abstract method for an enum? Not writing an implementation? Enum can have abstract method? Yes or no? If there is any abstract method, can we have objects? Our enum can have abstract method. Let's see that. And here we can declare this abstract, okay, but then we'll have to do something else. If you now you have your abstract method, okay. So we are saying this is a public and abstract method. Okay, so this is abstract now. But you have abstract method, you can't create objects unless for each object you are ready to give the method. See the syntax. The syntax is, oh, for this object, fine, that's the object. Fine. So for this object, I am overriding the abstract method compute, okay, which takes a double A comma double B. Okay, to return A plus B. And so this is what? I have this object, and immediately following the object, I'm saying, in case of this object, I am overriding the method like this. So this is the additional part which I have given. For each object, I will be mentioning the implementation for the abstract method. I can override a method like this. That should be fine. Okay, now if you want, we can add a main method and try out something. You can see that, observe, there's no conditional statement, there's no if anywhere. Let's write a main and see what we can. This A is matching this. Let me call it as args. Okay. Yeah. I didn't get it. One second. Okay. Yeah, thanks. Yeah. Okay. Let's compile. Oh, but I want you to observe something here, right? Okay, as I compile, just see this. What happens? Oops, we didn't have a successful compilation again. Oh, there's another place we still missed out. Okay, I'm compiling again. What do you observe? We got arithmetic operator, one class.